Okay. So, welcome everybody to my talk, Trace Compass, Past, Present and Future. My name is Bernd Hufmann. I'm working at Ericsson in Montreal, and I have been working at Ericsson since 2000. And I was working in several software development positions in Canada as well in Germany, in both product and tools development. And I'm also a Trace Compass project lead, which is an Eclipse project, and I've been there since 2010. So what you're gonna see today, first I wanna go a little bit in the background what Trace Compass is, then I want to show the history. It's been around for several years, so I want to go through the evolution of that project and what capabilities it has. I will look in certain use cases and give some outlook for coming up stuff. And at the end, we will have some time for questions and answers. So, Trace Compass. What is Trace Compass? Trace Compass is an Eclipse project, and it provides an open source application to solve performance and reliability issues by reading traces and analyzing traces and logs from a system. What Trace Compass also is, it also provides a framework for creating custom applications to solve performance and reliability issues of a system. So if the tool that is freebie downloadable from the project does not fit the bill, you can customize it and create your own extensions and make it available for your users. So about the history, 2009, Trace Compass started as part of the Eclipse Linux tools project. The goal was to come up with a framework to integrate different trace and log analysis tools. And the first real reference implementation was for LTTNG, which is a Linux tracing toolkit. And it was for the early 0x version. And that's why it was a perfect place to start off in the Linux tools project. And yeah, there were certain things already started. We had a kickoff of a trace research project in Montreal, and that is running over many years now. Over a few development cycles, and then 2012 LTTNG 2.0 came out, and Trace Compass added a support for that. Difference 2.0 provides a common trace format, so the traces are in the CTF format, and we have a Java parser for that, and this format can be used in different areas. So we have kernel and user space tracing and a tracer control for that. Initially, users had to install Trace Compass on an Eclipse IDE, and that's very useful for developers, but in some cases, users just wanted to look at traces and were not interested into the big IDE case with code editing and other facilities. So we created a standalone application, which was available at that time. And at that time, we also added an analysis framework. So you could add your own analysis based on traces to it. There's an extension point that is provided. And we added a few new types and trace types to the product. 2014, we decided to create a standalone project with the name Trace Compass. The reason was it was previously perceived that it's only for Linux and you cannot use it for something else. So it was always difficult to explain to users and customers in the open source community and in our company that you can use it for other types of logs. And so we decided to have our own project to increase visibility and have a better way to collaborate in the community. After that, we went into the performance analysis topic. We provided things for real-time and latency analysis. We have ways to do some pattern analysis based on traces. And one nice feature is a critical path analysis. By the way, later on I will go into each topic a bit more in detail so you can see views and features of that. 2016, traces, if you have information of function entry and exit, you are able to measure the time it's spent in a given function call. So if you have it available for all your call stack, then you're able to draw the call stack over time based on traces. So we added a few views for that, and that was a big topic in 2016. 2017, we created a incubator project, and the reason was that there is a common repository for people to try new things, provide trace parsers and analysis that right now maybe it's not meant for mainline, but it's important to bring them into the Eclipse community, so the IP due diligence and everything is done, and it's easy to mainline it if needed. And this add-ons is heavily used in our trace research project, where students and researchers add their results there and make it available in the community. So this year, cloud tracing is one of the topics. So we were thinking to have support for Jaeger tracing, which is a tracer that provides traces in the open tracing API. And we had a student intern in our company that provided a trace parser for it and some various views. Right now it's in the incubator project, but it's available. And coming up 2019, so this conference, EclipseCon Europe, we saw a lot of momentum around the Theia framework and having a distributed architecture. So we are thinking to go in a similar direction and to have a new front end so you can integrate the trace visualization in a web-based IDE. Quick note, I mentioned already, we collaborate with some academia. So there's a trace research project ongoing over many years with the University Polytechnique in Montreal. So every 4 years, it will be reviewed and there are new tracks coming out. So one is now finishing end of the year, and next year there's another one coming, and it's going into analyzing traces in cloud environment. So that's one of the tracks. But overall, it's traces coming from distributed applications, how to do it efficiently, how to visualize, and so on, anomaly detection, and so on. And the nice thing of that collaboration is that we get quite a bit contributions from the university, and right now we're around 30% commits coming from there. Now some technical things. So how does Trace Compass analyze and what is the data flow? So we start off on the left side, the trace file. That could be one single file, it could be many files. There are trace parsers that read the traces and create trace events. A trace event has a timestamp and some payload. And in the payload, depending on the application, you store more detailed information. So with that, you have streams of events, which can be shown as raw data in an events table in our case. From there, we can provide more analysis. So looking at each field content and try to analyze what's going on. That result is stored in some intermediate representation on disk mainly, and then there are views that take that data and visualize it. So the blue is more a example. So CTF, it's a generic trace format. So that's built in if you have a trace in that format. So Trace Compass can open it right away and it's available. We have support for, we have some binary parsers like GDB trace points or PCAP. And yeah, we have a text wizard to provide text and XML parsers. But like I mentioned earlier, it's a framework. So if you have some type of traces that are not fitting the built-in ones, you can extend it and create it your own. And having the analysis framework, you can add, can use the existing ones or add your analysis in as a Java plugin, or there's a way to provide some XML definition so you can do it on the fly. Now I'm gonna go in some of the features. So events table, you see the raw events, you have a column for the timestamp, some other informations, often there's an events type, and then the payload, the content, where you really see the detailed information of per event. And yeah, the events are ordered by time, and if you have multiple traces in a trace set, then it orders at the times that it traces according to the time, and that's very useful if you have traces coming from different nodes or different layers in your application, so you can really follow the whole stack of execution. You have highlighting support, so you can color code certain events. There is searching and filtering capabilities in there, so you can find certain things. In that case, I highlighted function entry cases. And there is a way to bookmark events. On the left, you see a little blue icon, and you can bookmark it. And from the bookmarks view, you can always navigate back, so it's easy to find places. System tracing, yeah, the default implementation we have is for Linux tracing. Linux Tracing Toolkit, LTTNG, it provides kernel analysis and user space. And for kernel analysis, it hooks on to the trace points that the Linux kernels provide and stores it in their way in CGF. But the interesting thing is it's the same trace points that other tools use, like perf or ftrace, and we are able to populate the views also from the other traces. Here's an example of a Gantt chart that we use to visualize dates over time. In that case, we show Linux resources. So the rows, you see it separated by CPUs. So second row, CPU states, so you see what one CPU is doing at a given time. If you are in user mode or function call, or if it's interrupted or so on. The CPU threads is really saying, okay, at that given of time, that thread is running. So that's for example, if you have a periodic task, that task has a certain color, and you can really see that a pattern how visually, and maybe you might spot a long execution. And with tooltips, you always get more information on a given state. Yeah, you also have support for IRQs and soft IRQs. So these types of view, we have a way to find and highlight certain things. So that's a pretty recent feature. So if you press slash, it opens that window, and you can add a regular expression to find certain things. So now, in my example, I looked for the program sort, and where it's matching, you keep the color, and everything else is dimmed out. And from there, if you don't want to see the other things at all, you can filter it out. So that's a very, very powerful feature. Another example for Linux, you can draw CPU usage and memory usage. So that's two good examples. So highlights, you can follow CPUs, IRQs, you can follow thread executions, find high processor loads, memory usage, and you have support for enhanced filtering. Next topic, latency analysis. So in each trace event has a timestamp. So with the timestamp, you can measure executions. So you can go from a start to an end. Sometimes it's just the difference between two events. In other cases, you need to have a little state machine to measure the whole thing. For example, you might need to look at the process ID to have a state machine per process. So you measure the start to the end, and then there are ways in Trace Compass to store that data and visualize it in various views. So built in, we have a table with the raw latencies, show it over time or in some density. The statistics is very useful to give an overview what's going on. So you have it, the latency, you have the minimum, maximum, some average, standard deviation. So it gives you some feel how your application is working, and you can navigate to your maximum. Critical path, in the Linux kernel, we analyze the system weight chains for a process, and you can also follow it across the network if you have multiple traces for multiple nodes, and you have a message exchange between it. And what it does, it looks at the weight chains and see what is my process of interest is waiting. So you see if it's interrupted, preempted, waiting for a timer or other resources. So that's very useful, analyzing the critical path. We have a default implementation for Linux, but the whole code can be useful for other use cases. And a funny story, recently we had some problem with ls-s command. It took seconds at in our environment in Ericsson. And a colleague of mine used Linux tracing at TTNG and traced that command and used the critical path to see why it took so long. So he was able to figure out what's the reason. And once we knew that, the system admin or the people were able to change some configurations. And so that's very interesting. So latency analysis highlights, find long latency, critical paths, and you can use it for performance investigations. Call graph analysis. So if your trace provides information from function entry and exit, we can show the call stack over time. And there is a few, it's called flame chart, which is time-based. And right by default, it's populated by by LTD&G user space application that was compiled with F-instrument functions and connected to the Linux LTD&G tracer. So you get a graph like this. You can navigate, find certain executions over time. But starting from there is sometimes difficult to find the area where you want to start investigating. So flame graphs are very popular right now in the industry. So basically, you take each call stack and aggregate each execution, each duration, and then you plot the aggregation. So you see what your application is spending time on. So that can help you to kickstart your investigation and say, like, in these functions, we spend a lot of time, let's see why. And then you use the other views to find the root cause. So the same information we also plot as with some statistics. So each function, you get some statistics about that. Highlights, you can use do some profiling using trace data, and you have various views for that, like the flame graph. I mentioned it earlier. I quickly come back. Trace Compass add-ons from the incubator project right now. Get more analysis, more trace types. There's virtual machine analysis, container analysis in there, and Jaeger analysis, which I will go over a little bit later. And in the standalone application, we have a market client support, so you can install it from there. And of course, there are update sites. Open Tracing API. So Open Tracing API was created to have a standard way to trace executions in a cloud environment. They are implemented trace microservices, and you can follow your executions and spans across services. So we did some work to support traces from Jaeger, and once you have the parser, we were able to show it in the events table with the events detail to get the traces very easily. You can either use the JSON file that you can export from their UI, or you use the HTTP command. There's a little fetch dialog to get it in. And so the span live view, if you're familiar with the UI, the web UI from Jaeger, it provides you similar information. You have all the spans and executions and so on. And you get the log information as tooltips, and you have each log as a marker. So you can go there and get the tooltip. So the highlights, well, if you're happy with the Jaeger UI on the web, you can definitely use it, and it's a great tool. Interesting part with Trace Compass is that you have a way to correlate to system traces. So you have your spans, but if you want to see what happens on the operating system level, and you can really drill down, you can put it together and see why that span took so long on that machine. So that's why we started looking into that. And we tried to implement a critical path analysis on that. Because if you have a huge cluster and you need to reduce the number of span to show in the view. So with a critical path analysis, it only shows the spans that really contributed to it. So that was what has been done up to this year. Now I would like to look into the future. So Trace Compass is a typical monolithic application. It's Eclipse-based. We have like some data store, the trace and intermediate data. You have core components for analysis and to store that information in intermediate storage, and then the UI is taking that stuff and creates different graphs. So what we have done a bit recently, do some restructuring of our architecture. So we added some concept that is called data providers. So going from the core components, we get the data in a way that is independent from the UI, and we can send it to the UI, which takes it and visualize it. And with that, the data provider are meant in such a way that you can serialize the data. So once you are able to serialize the data, we can send that information over a protocol somewhere else. So you can really now decouple the trace server implementation with the UI, with the presentation layer. So this is our proposal to a way forward to have this layered architecture. And for the protocol, we think we can have a similar concept like the language server protocol. So it's really decoupling the UI and the core. And it will handle the communication between the core and UI of the trace viewer. There will be provisioning to manage traces, or say, okay, I post your trace, I delete traces, and so on, put multiple traces together. It will have support for different visualization types. Yeah, a way to provide filters on the server side where you reduce the number of data sent over. And what we don't think, and we don't, it's not in scope of the trace server protocol, would be the tracer control. So how to enable traces on a target. We think that should be a different entity, and each application has the operating system have a different way to create control the traces. So this year we did some prototyping. We defined a protocol. It's very preliminary. We did a REST API over HTTP. And then we created a trace server in the Trace Compass incubator project, which has just core components of Trace Compass and no UI dependencies. And with that, we were able to do some proof of concepts for visualizations on a different front end. And that work was done in collaboration with our research partners, and we got quite good help from that side. So why would we want to do that? One reason is, we can leverage modern UI technologies and other programming languages than Java and within Eclipse. With the integration with other web-based services should open more opportunities. For example, CI integration. So what you could do with a trace server is you run your CI job, run your unit tests with tracing enabled, and after that the traces could be posted to a trace server, and you can do automatically some analysis and present it on your dashboard. And with good workspace management tools, you could then get the traces in your working environment and start investigations. It's really about making things the investigation loop faster and help kickstarting investigations if something goes wrong. Yeah, if you're web-based IDEs, so we can leverage the latest language server and debug server. And that architecture, I think, enables microservice architecture. So we can distribute trace analysis and which what we want to achieve is higher scalability. If you have traces that spans or are bigger than one single disk. That's basically what I had. In my slides, I have some references, contacts, and yeah, please evaluate the talk. And I'm ready for question answers. Yep. Live streaming, yes. Right now it's not supported. We have it on our roadmap, and our users have provided that feedback that they would like to see it. We want to have it, but it depends on priorities. But it's definitely on the radar to have live streaming. But right now I cannot say where it comes. But live streaming, there is always two levels. There's streaming from your application to the tracer to create the trace files, and then there could be streaming from there to the visualization, so you monitor. So that part is on our turf mainly, and right now we don't have support. Clock synchronization. Yeah. Yeah. Yeah, yeah. Yeah. So there was a research track ongoing about that, and there was a that feature is now integrated in Trace Compass. So based on network exchanges, TCP exchanges, there is an algorithm to detect clock changes, and it's an automatic time adjustment, and that's part of Trace Compass using traces from LTTNG and network exchanges. However, the whole algorithm is available. So if you have a different way to match events from two nodes, that could be then implemented and fed to the same algorithm to automatically adjust the traces. So there is provisioning and support for that. The question is, do we have a database for the analysis result or for the traces? It's per use case, so most of the time traces are just files. So that's one case. In other cases, like the Jaeger tracing, they have a database when you use a tracing, and there is a UI to fetch that. But in most cases, it's file-based. And the intermediate data to create these Gantt charts, to be able to store a lot of data. If you have large traces, we have an intermediate representation on disk, like a history tree. And with that, you can, the views are querying the data for the given time range which you zoomed on. Yeah, it's available as plugins. You just install it. In fact, CDD EPP includes it, the main features, the Linux tracing one and the framework, but you can put it in any other Eclipse IDE or RCP. For the time synchronization, there's a way to match the events on the content of the TCP messages. So that's the correlation. In other cases, well, you know from the trace file where it comes from. So that's one correlation point. In Linux, we have also support like for host ID, which are stored in the ATT&G traces, and which is reused to be able to say, okay, that's from that host and that's from that host, because TIDs, thread IDs might be the same one on two different nodes. So you have to know if it's from one file trace node and from the other. So it depends on the application. Okay. Flame graphs, yes. The question was, is it possible to show flame graph from Jenga? Jaeger trace. Not right now. We worked a bit on it, but I don't think it was finalized. But yeah, would be interesting. Okay. I think we're running out of time, but we can talk about that afterwards. Thank you very much.